Okay, class, in this lesson, you are going to learn to calculate the future value of a periodic deposit investment. Okay, so let's go ahead and get started. So here's the question. How can you effectively plan for the future balance in an account? Okay, so in a previous lesson, you learned the value of an investment with a single deposit, but this time we are going to learn the value of an investment with multiple deposits. Okay, so we also know that the balance your account grows to at some point in the future is called the future value of a single deposit investment. And we learned that a single deposit investment account is one in which no further deposits are made after the initial deposit, hence the term single deposit investment. And we also learned that to calculate the future balance, we use the compounding interest rate formula. And let me go ahead and correct that. That should say interest rate. Interest rate formula. And that formula is the future value, so the balance at the end of the time or term, is equal to the principal or the initial amount times this quantity, 1 plus the rate in decimal form divided by the compounding frequency raised to the compounding frequency times the number of years. Okay, and a periodic investment is the same deposit made at regular intervals. Okay, so very similar to a single value, but now we're doing a periodic investment. And so we have deposits that are being made, for example, yearly, so on an annual basis. Every year, the same number of deposit is made, or on a monthly, bi-weekly, weekly, or daily basis. Okay, and the equation to calculate that is the principal amount, so the initial amount, times the quantity 1 plus the rate in decimal form divided by the number of compounding raised to the number of compounding times the year minus 1. Okay, and that is all divided by the rate divided by the number of compounding. Now this equation looks a little complicated, but as you will see, the equation up here, the future value of a single deposit, this P times this quantity, is embedded in here. Okay, so the only difference here is we're going to subtract 1 and then divide it by R over N. So don't let this formula scare you away. All right, so let's go ahead and take a look at this first example. We're told that Juan and Eva are opening a joint account and deposit $5,000 each year that pays 1.2% interest, and that is compounded annually. And the question is, what is that account balance after 20 years? Okay, so Juan and Eva are making a deposit of $5,000 every year for 20 years. All right, so to solve this equation, we're going to go ahead and replace the principal amount, which is $5,000. That's how much that they're making. And this is going to multiply by 1 plus the rate in decimal form. So this is going to be 0.012 divided by the compounding amount, which in this case is annually. So really that's just 1 raised to the compounding amount, which is 1 times the number of years. That's 20. Okay, and we're going to subtract 1, and that will be divided by the rate, which is 0.012, divided by the compounding frequency, which is 1. And if you punch this into the calculator, you're going to get the value of $112,000, 264.32 cents. $112,264.32. Okay, so that will be the ending balance after 20 years. if they make $5,000 deposit every year that pays 1.2% interest compounded annually. Okay, so in this next example, the question here is, how much will Juan and Eva earn over the 20-year period? Okay, so we know that Juan and Eva make a $5,000 deposit every year for 20 years. So they've actually contributed over that time period a total of $100,000. And we want to know how much they've actually earned. So this is related to the previous example. We want to know how much they've actually earned. Well, we know that the final balance is $112,000, $112,264.32. Okay, we calculated that in example 1. So if we subtract the $100,000 that they contributed, then their earnings will be $12,264.32. Okay? All right, let's go ahead and move on to our last example, example 3. So now we have Jose and Maria open an online savings account that has a 3.8% annual interest rate compounded monthly. If they deposit $1,200 every month into this account, how much will be in the account after 10 years? Let's go ahead and utilize this equation and substitute the following values. So the principal is going to be $1,200, right? So they are depositing $1,200 every month, and they're going to earn an interest rate, annual interest rate of 3.8%, so that works out to 0.038 in decimal form. This is compounded monthly, so the compounding frequency is going to be 12, and that's going to be raised to the 12 times 10 years, okay, minus 1, all divided by the rate, which is 0.038 in decimal form, over n, or the compounding frequency. And if we punch these numbers into the calculator, we would get $174,848.93. Okay, hopefully that made sense. If any of this was confusing, please go back to the beginning of the recording and listen to it again. Thank you.